Welcome to our video lesson on finding the GCF. In this video, we're going to go over two methods you could use to find the GCF. I know you've done this before, so hopefully some of it should look familiar. Alright, let's start with the first one. The first method is listing the factors. What I need you to do in your guided note is write down these steps right here. Write them down so you have them to refer to later, and when you're doing your practice, you can check and make sure you're doing it properly. So pause the video and write those down. Alright, now that you have your steps written down, let's do this example together. Make sure you fill it in on your guided note as I write it down. So find the GCF of 48 and 64 using the listing factors method. Over here, our steps say the first step is to list the factors. Factors, remember, are two numbers that when multiplied together give us this number. So I'm going to start by putting 48 over here. Our first factor of any number is always going to be 1. It is 1 because 1 can be multiplied, and 1 is a factor of every single number out there. 1 and then itself. And I'm going to write itself way over here because hopefully we can write them all in order. The next thing to do is use your divisibility rules that we talked about today to try and figure out what else this number is divisible by. I like to go in order so I don't miss any. Alright, is 48 divisible by 2? This number here is an even number, so yes, it is divisible by 2. So I'd write 2 and then think to myself, okay, 2 times what gives 48? Well, if you're not sure, you can do the division on the side. No problem. But I know that 8 divided by 2 is 4, and 2 divided by 4 is 2. So it's going to be 24. Next one is 3. Check out your divisibility rule for 3. It's that if you can add up both digits and your sum is divisible by 3, then your number is divisible by 3. 4 plus 8 is 12, which is divisible by 3. So we know that it will be divisible by 3. What times 3 gives 48? This one's a little bit more challenging, so maybe we should do it on the side. How many times can 3 go into 48? 3 times 1 is 3. We subtract that and we get a 1. We bring down the 8. How many times can 3 go into 18? That's 6 times. And 6 times 3 is 18. We subtract it, get a 0 remainder. Awesome. So we know that 3 times 16 gives 48. Alright, number 4. The divisibility rule for 4 is if the last two digits are divisible by 4, then it is divisible by 4. 48 is divisible by 4, so we can write down our 4 here. And what times 4 gives 48? Well, 4 goes into 8 twice, and 4 goes into 1 once, so it will be 12. Then next one will be 5. Is 48 divisible by 5? Our divisibility rule is that if it ends in a 0 or a 5, so it doesn't, so we know it's not divisible by 5. Alright, 6. Is 48 divisible by 6? Yes, it is, because we know 6 times 8 is 48. Two more divisibility rules. Is 48 divisible by 9? You look at the last two digits, and if they are divisible by 9, it is divisible by 9. 48 is not divisible by 9, so we can rule that one out. And then 10 is the last digit a 0? 8 is not a 0, so we are done. Okay, that was a long one. Now let's do 64. We always write down 1 because every single number is divisible by 1. And we write 64 as well because 1 times 64 gives 64. Next one, 2. Is the second or the last digit even? Yes. So 64 is divisible by 2. What times 2 gives 64? We can check it on the side if you want, or you can do it in your head. I know it will be 32 times 2 gives 64. 3. Is 64 divisible by 3? Remember your divisibility rule. You take each digit, the 6 and the 4, and add them together. 6 plus 4 is 10. 10 is not divisible by 3, so 64 is not divisible by 3. Alright, let's do 4 now. Is 64 divisible by 4? Are these last two digits divisible by 4? I think they will be. Let's check it out on the side. 64 divided by 4. 4 goes into 6 once. 1 times 4 is 4. Subtract 6 minus 4, we get 2. Bring down the 4. 4 goes into 24 6 times. 6 times 4 is 24. We subtract them and get a remainder of 0. So yes, 4 goes in to 64 16 times. Alright, then we have 5. Is 5 divisible by 64? Does it end in a 0 or a 5? No, so 5 isn't divisible by 4. For the rule for 6, is 64 divisible by 2 and 3? It is divisible by 2, but not by 3, so it's not divisible by 6. 8. Is 64 divisible by 8? Yes, we know that 8 times 8 is 64. 9. Is 64 divisible by 9? Can we add the digits up and be divisible by 9? 6 plus 4 is 10, and 10 is not divisible by 9, so we know it can't be divisible by 9. And then 10. Does 64 end in a 0? No. Okay, now we're done. That was a long process, but we can check off our first step. We've listed the factors. The next thing to do is circle any shared factors, any common factors that they both have. Right, they both have 1. They both have 2. They both have 4. They both have 8. They both have 16. And that's it. Done step 2. Then step 3 says the biggest one is the GCF. So in this case, the GCF, the greatest common factor of 48 and 64, must be 16. And we're done. Seems like a long process. Let's see if there's another way. Method 2 is using factor trees. You should have worked with factor trees last year. Factor trees is where you break down the number into multiples that it can multiply to make and then move down further. We're going to find this GCF of 28 and 42 using factor trees. Please write this down as I do it. Okay, the first step is to figure out what you can divide into 28, or what two multiples you can multiply together, or factors, to get 28. I'm going to do 2 because it's an even number and that's an easy one to do. 2 times what is 28? It's 14. If the number that you get at the bottom of this stick here, these sticks, is a prime number, meaning it can only be multiplied by 1 and itself, circle it because it's the end of that line. So 2, the only two numbers that will make 2 are 1 times 2. Whereas 14 is not a prime number, so we're going to keep going. What can give us 14? I'm going to say 2 times 7. And 2 is a prime number, so I will circle it. And 7 is a prime number as well, so I will circle it. And because all our numbers are circled, we are done. So we've written a factor tree for 28. Let's make one for 42. 42 is also divisible by 2, so I'm going to do that right off the bat. 42 divided by 2 is 21. Again, if you'd like to do it off on the side, you're definitely welcome to. 2 is a prime number, so I'm going to circle it. 21 isn't prime because 7 times 3 will give you 21. Also, 3 is a prime number because 1 times 3 is 3, and 7 is a prime number. So we've written a factor tree for each number, and we've circled the last number in each tree. The next step says write the prime factorization. Prime factorization is just a fancy way of saying write the circled numbers together so that they multiply together. I'll show you what I mean. 28 is equal to 2 times 2 times 7. So I'll write 2 times 2 times 7. And that's true. If you take 2 times 2 times 7 and multiply it together, you will get 28. And 42 is equal to 2 times 3 times 7. That's just the numbers from here. And that's the prime factorization. Then it says circle the common factors. I'm going to change my color here. Circle the ones they have in common. So